We're the Nerf Boyz, and we have a new and improved design concept for the Nerf Maverick REV-6. The previous model lacked the necessary firing distance and reliability to be effective in an intense Nerf battle.
Come on!
Jamming significantly affects the reliability of the gun. The sluggish reload speed allows other guns to fire more projectiles while the Maverick was being reloaded.
Cover me, I'm reloading!
As you can see, the barrel extension of the unmodified Maverick is limited, interfering with the user's ability to reload the gun efficiently and return fire to enemies. The flat surfaces of the cocking mechanism are difficult to grasp with sweaty hands in the heat of battle. The lack of the safety feature allows the gun to be live to fire at all times.
Sorry.
Because of these issues, the N.M.R.6.R.2 was upgraded based on the three main subsystems of the gun. These modifications and upgrades have a minimal effect on the cost of production of the N.M.R.6.R.2. The first subsection improved on the N.M.R.6.R.2 was the barrel subsystem. The barrel subsystem consists of the revolver portion of the gun that is responsible for loading and storing the darts. The air limiters reduce the amount of air that is transferred to the projectile. By removing them, the gun will have an increase in firing range. Also, eliminating these parts from the design will decrease production cost and time. The product originally features a cumbersome barrel arm extension that allows for one projectile to be loaded at a time. By removing just a bit of material from the barrel arms, the barrel will be able to flip out farther than the original design. The barrel flip out will increase the reloading time by an average of 4 seconds. That's a 32% improvement when compared to the average reload speed on the original design. There is no change in the production cost because the injection mold will be almost exactly the same. Another way to improve the reload time is to alter the barrel arms to make the barrel array interchangeable. This modification needs to be made concurrently with the extended barrel flip-out modification to allow the user to access the part of the barrel arm that allows for the barrel array to be removed. With this additional improvement to the barrel subsystem, the reload time can be as short as 3 seconds. This is a 9.5 second improvement from the original design. Now you can return fire at a faster rate than before. This also has a minimal effect on the production process. The parts are injection molded, so a slight modification to the injection molding will not significantly affect the current cost of the gun. The trigger subsystem is responsible for the user input to fire the projectiles from the gun. We implemented an improved trigger interface. It can now be more comfortably gripped by all users and decrease fatigue during rapid firing. Filleted trigger face will serve to minimally reduce the amount of material on the product. This change is unlikely to affect the cost of production. The overall safety of the gun should be of the utmost importance. For this reason, the group tackled the problem of accidental firings. A brand new feature has been added with the trigger safety. Now you won't accidentally injure your own teammates. Our push-button safety minimizes the possibility of accidental firings. The safety utilizes the geometry of the trigger as well as a slotted cylinder to impede the motion of the trigger when the safety is engaged. This is a whole new device that would be implemented in the production process. The price for the new parts would add a material cost of $4,400 per million parts produced. The cocking mechanism subsystem is where all energy is received, stored, and released to fire the gun. To increase the firing range, the team decided to implement a stronger firing spring. The spring directly affects the rate that the air cylinder is compressed. With the improved spring, the user will be able to hit targets at greater distances. The use of a stronger spring in place of the weaker original will not likely increase the production costs of the product. The use of a stronger spring requires the user to input more force to cock the gun. The cocking handle allows the user to obtain a better grip on the cocking mechanism to more effectively cock the gun. In the original function of the product, the projectile would fire as the barrel array is rotating due to the use of the trigger motion to rotate the barrels. This simultaneous action decreases the accuracy of the product because the barrel is rotating as the projectile is being expelled. By decoupling the trigger pull and barrel rotation, the team has increased the accuracy of the product by allowing the barrels to remain stationary as the projectile is fired. This modification will likely increase the cost of production because it will require additional parts and changes to be made to the product. There is just one injection molded part that would fit into 2 new slots in the gun. This is estimated to add about $6,000 per million parts in production. However, the team feels that the increased accuracy will outweigh the minimally increased price of production. In an effort to reduce the jamming rate of the gun, the front shroud was completely removed. Jamming would primarily occur when the projectile became lodged between the barrel and the shroud as the barrel array rotated. With the shroud removed, there is nothing for the dart to get caught between, thus eliminating the threat of a jam occurring. The plastic removed will save almost 80 cents per part. Over 1 million parts, the savings amount to $806,000. This cost savings makes this improvement important, even with the overlapping solutions like the linking barrel rotation improvement. This design significantly improves the form and function of the former model Nerf Maverick REV-6, improving the barrel, trigger, and cocking mechanism subsystems. Thank you for your time, and don't hesitate to contact us if you have any questions.